Hello friends, welcome to our lectures today. On our lectures today, we're going to be studying some examples that will help us understand the concept of indices better. Now, in the previous video, we studied the laws that govern the operations of indices, and right here we're going to be studying some examples that will help us understand that better. For example, we are given a question right here, and in this question we have 8 multiplied by 2 raised to the power n plus 1 divided by 2 raised to the power n plus 3. So from the laws of indices and from indices generally, we know that 8 can be expressed in index form. What do we mean by index form? So what numbers do we multiply to get 8? That's what we're asking. So we can multiply 2 times 2 times 2. So we multiply 2 3 times and that will give us 8. So we can write it as 2 raised to power 3, giving us 8. The power is 3 because there are 3 2's there. Okay, back to our question. So we have 8 being 2 raised to power 3 multiplied by, now we leave this 2 raised to power n plus 1 now, just the way it is, 2 raised to power n plus 1 divided by 2 raised to power n plus 3, 2 raised to power n plus 3. So what we have in this case is that we can pick one of the 2's here, and because of the multiplication sign in between them, according to the laws of indices, we add up the powers. So we have 2 raised to power 3 plus n plus 1. Now here also, this 2 and this 2, we can just pick one of them, right? We can just pick one of them, but because of this division sign in between them, we have to subtract the powers. So we have minus n plus 3. So this gives us, let's use the signs to open the brackets before we move on. So 2, now here we have 3 plus n plus 1. So what we do in this case, the positive sign does not really change anything within the bracket, so we can choose to write that out the way it is, because plus times n still gives us positive n, and positive sign times positive 1 still gives us positive 1. So that will be plus n plus 1. But the case is different here for the negative sign. Why is that so? Because negative sign here multiplied by n, which is a positive n, gives us minus n. So this minus sign multiplied by the positive 3 changes the sign and gives us minus 3. So let's collect the like terms and see what we have. So let's put numbers to number and alphabet to alphabet. So we have 3 plus 1 minus 3. Those are what we have. Plus n minus n. Right? How true, how true. So here, this gives us, now 2 raised to power 3 plus 1 minus 3 plus n minus n, right? That's what we have. So 3 plus 1 gives us 4. 3 plus 1 gives us 4. Let me write that 2 now. Now 4 minus 3 gives us 1. 3 plus 1 gives us 4. And 4 minus 3 gives us 1. So what we do here is we can write 1. Now let's move over here now. Now positive n minus n, that will give us 0, so they cancel out. So we are left with our answer being 2 raised to power 1, which we can choose to evaluate as 2, and that will be our final answer. Now let's play with one more example and see how it goes. Here's another question, and we could be giving these sorts of things to evaluate using the laws of indices. Now in this question, we are going to be applying some of the laws we taught on in the previous video. Now recall that if you're given a raised to power 1 over 2, we can choose to write this as the square root of a. How is this possible? Because the denominator of your fraction at your power here becomes your root. In the same way, if you have a raised to power 1 over 3, right? So in this form, you're still going to have that this becomes the cube root of a, because the denominator at your power becomes your root. So if we then see the fourth root of a, we can choose to write this back as a raised to power 1 over 4. However you want to do it, right? However you want to do it. Now, this is what we're going to be doing in this question. We're going to be converting these square roots and cube roots, as the case may be, to powers. Let me take this off the screen and let's continue with our question. So we have that this becomes 8x cubed y raised to power 6, right? So this 3 at the root here becomes our power. So we take the reciprocal and it becomes our power. So it becomes 1 over 3, right? So the third root becomes 1 over 3 divided by, now we have here 1 over 25, 1 over 25, 1 over 25, 1 over 25, and here still x raised to power 4, x raised to power 4, y raised to power 7. Now this is a square root sign, right? So we can write that as 1 over 2. Write that properly. 1 over 2 as the power. 1 over 2 as the power. Now, the last part we have multiplied by, now here we have 16. 16. Notice there is already a 1 over 2 at the power here, so we have to also convert these roots here to 1 over 2. So this becomes x raised to power 4, y 4 now, y raised to power 6, right? The square root becomes the power. So don't forget we also have another power of 1 over 2 outside the entire bracket. Now this gives us, remember that we can choose to write 8 as 2 raised to power 3, right? So we can write that as, now I want to distribute the powers across each of the variables within the bracket. In this place here, I also distribute it, and here also I also distribute the powers, because the last law we studied in the previous video told us how we can distribute any power we are seeing among variables within that bracket, right? So here we have it that let me enclose this in square brackets, so I'm going to have a lot of things to write. We have 2 raised to power 3 being 8, 2 raised to power 3, that's 8. Let me write this 3 properly. Yes. Now, I'm distributing this 1 over 3 across every variable within the bracket. So I have 1 over 3. Now, the next is ox raised to power 3. Ox raised to power 3. It gets its own 1 over 3. The next is y raised to power 6. Y raised to power 6. And it gets its own 1 over 3. 1 over 3. So we're done with that bracket. Let's distribute the power in the second bracket across all the variables within that bracket. Divided by, now it's worthy of note to let you know that we can choose to write this 25 here as 5 square, right? So this becomes, let me put that in square brackets. Now 1 over 5 square, 5 square. Now each of them gets the power of 1 over 2. 1 over 2. It gets the power 2. Here also x raised to power 4 x raised to power 4 also gets the power of 1 over 2. So this power is multiplying everything within the bracket. It's multiplying the powers within the bracket now. So we are also having that here we're going to have y raised to power 7, and it itself gets the 1 over 2, and itself gets the 1 over 2. Now let me enclose these square brackets. Now the last bracket here, let me evaluate that quickly. We have a multiplication sign. We have 16 beginning that bracket. 16, and I could also choose to write 16 as 4 square, right? So let me write that as 4 square. Now here we have x raised to power 4. Now this first power of 1 over 2 here would be distributed across x raised to power 4 and y raised to power 6, but it doesn't affect this 16, right? But it's this power outside, this 1 over 2 outside the entire bracket, that affects everything within the bracket. So let's take it step by step and let's see how it goes. So we have x raised to power 4, x raised to power 4, and this initial 1 over 2 within the bracket is distributed among itself and y raised to power 6. So this will be 1 over 2 as the power of x raised to power 4. Also, y raised to power 6 also gets 1 over 2 as the power. Don't forget that at the outside of our entire bracket, we also have another 1 over 2 as the power. So this gives us, we know that this is multiplication, right? So we can choose to cancel here 3 here 1 and 3 here 1, right? The same thing applies to the entire bracket. So this goes, right? 3 cancel here and 3 cancels here. Now 3 here 1 and 3 into 6 gives us 2, right? Let's move on to the next bracket. Now this square root here cancels this 5 square, and even if we were to write 1 square here, the square will also be cancelled, right? So here also 2 here 1, 2 into 4, 2, right? Now we can't divide this directly, so I'll leave that just the way it is. Now here we have 2 here 1, and 2 into 4 will give us 2. 2 here 1 and 2 into 6 will give us what? 3. So let's bring out what we have left and let's see how it goes. Now here we are left with 2 multiplied by x multiplied by y raised to power 2. So this gives us 2x y raised to power 2. In the second bracket we have divided by. Now we are left with just 1 over 5 here, right? So this will give us 1 over 5. And in the next bracket we have x raised to power 2 only remaining there, x raised to power 2, x raised to power 2. And in this bracket we have, now because we did not divide it directly, so we can choose to write y raised to power 7 over 2, y raised to power 7 over 2. So multiplied by, well, in this last square bracket now, so multiplied by, now 4 square still remains 4 square, nothing cancels out there. Now here we have just x square left, x square, and here we have y raised to power 3, Don't forget that we have is 1 over 2 as the power of the entire bracket. So that power will also be distributed. Now at this point now we can choose to rewrite 2x y raised to power 2. Now here we can also write divided by, if we multiply these out, we're going to have x square y raised to power 7 over 2 divided by 5. Now here also we have that this power is distributed across everything within the bracket. So 4 gets its own, and we have 4 square raised to power 1 over 2, right? Here x also gets its own, that is x square gets its own there, so x square raised to power 1 over 2 also. Now let me lift this up a bit. Now here we also have y cube getting its own power of 1 over 2. So you notice that this cancels out and this cancels out. The powers here cancel out, the powers here cancel out, and the powers here also cancel out. So this can't cancel out directly, so we leave it exactly the way it is. So in the next part we are going to have, now notice that we can change this sign to a multiplication sign by inverting this fraction. So this becomes 2xy square multiplied by, now as I'm converting this sign to a multiplication sign, I'm going to invert this fraction here. 5 divided by x square y raised to power 7 over 2. Here we are left with 4, right? 4, then x, 4x, y. Now this y, the power did not cancel out, so we're going to multiply them out directly, and we're going to have y raised to power 3 over 2. Y raised to power 3 over 2. Now let's multiply this part and this part together, and let's see how it goes. So 5 times 2 gives us 10. Now we're going to be having x y square divided by x square y raised to power 7 divided by 2, 7 over 2. So still multiplied by 4x y raised to power 3 over 2. Now from the laws of indices, we have that this could be giving us 10. Because this is a division going on here, we can choose to pick one of the symbols and subtract the powers. So that will be x raised to power 1 minus 2. Notice that there's an imaginary power of 1 here, and here we have a power of 2. So the same thing happens for the y. Y is going to be raised to power 2 minus 7 over 2, still multiplied by 4x y raised to power 3 over 2. Raised to power 3 over 2. So in the end we are left with 10. Now x, now this power here, 1 minus 2 gives us minus 1. Then here we are left with y. Now if we should subtract this fraction from 2, let me quickly play with that. So we have 2 minus 7 over 2, right? 7 over 2. So the LCM here would be 2. And there's an imaginary 1 here. So 1 into 2 gives us 2, and 2 times 2 here gives us 4. Now 2 into 2 here, 1 times 7 still gives us minus 7, right? So in the end here we're going to be having minus 3 over 2. So let me take that off quickly. So we have minus 3 over 2, still multiplied by 4x y raised to power 3 over 2. So we can multiply directly, right? We can multiply directly and see how it goes. Now, because of the multiplication sign there, we add the powers of similar variables, right? Now, the first is 4 times 10. 4 times 10 here gives us 40. Gives us 40. Now, we have x raised to power -1 and x raised to power 1 here. So we're going to add the powers. So it's going to be x raised to power -1 plus 1, right? X raised to power -1 plus 1. Then y raised to power. Now there's a minus 3 over 2 here, and there's a positive 3 over 2. So we're going to add the powers, right? So that's going to give us minus 3 over 2 plus 3 over 2. Now here we have that this gives us 40. Now x raised to power -1 plus 1 gives us what? X raised to power 0, because -1 plus 1 is 0. The same thing happens to the y. Minus 3 over 2 plus 3 over 2 gives us 0. So in the aftermath, our answer is, now remember that anything raised to power 0 is 1, right? So x raised to power 0 becomes 1 and y raised to power 0 becomes 1, and our final answer is 40. Thank you so very much for watching. Please do subscribe and please do ring the notification bell to get more of our content. Remember, knowledge will change your life forever. How true, very true, very true. See you in the next video.